All right, today we're going to learn how to solve a rational inequality. It is a different process than solving equalities. There are some similarities, and so we're going to go through 3 examples, and then I'll give you some problems to try on your own. So when I look at this rational function, I want to know values of x that make this function less than 0. So you're going to first look at what we call the critical numbers. And those are the zeros of your factors. So I want to think about at x minus 1, my critical number is 1. And at x minus 6, my critical number is 6. And at x plus 4, my critical number is negative 4. Now I'm going to place those numbers on a number line. It doesn't really matter if I space them out appropriately. I just need to get them from largest to smallest so that I can mark my number line off in intervals. So the smallest of these 3 numbers is negative 4, followed by 1, followed by 6. So this number line is broken down into 4 intervals. I have the interval from negative infinity to negative 4, from negative 4 to 1, from 1 to 6, and 6 to infinity. I want to pick the intervals that actually make this fraction less than 0. And what all numbers that are less than 0 have in common is that they're negative. So I'm going to pick numbers that are inside these intervals. So a nice number between negative infinity and negative 4 could be negative 10. You get to pick whatever number you want. A number between negative 4 and 1, I'll probably pick 0. Between 1 and 6, any number you want, I'm going to choose 4. And between 6 and infinity, I'm going to choose 10. These are my test points. When using test points, every number inside that interval behaves the same way. So if negative 10 makes this fraction less than 0, then that interval will be a solution. So I'm just going to plug it in. I don't care what the number is. I just care if the number is positive or negative. So when you replace x equals negative 10 into the factored form, negative 10 minus 1 is negative. Negative 10 minus 6 is negative. Negative 10 plus 4 is negative. If you multiply 2 negatives and divide by a negative, you have an odd number of negatives. The overall value in this interval will be negative. Therefore, at negative 10, this function is negative, and so is every point in that interval. That interval is a solution. I'm going to substitute 0 in. Now, I'm not going to show you where I plug 0 into this function. I'm just going to do that part in my head. But 0 minus 1 would be negative. 0 minus 6 would be negative. And 0 plus 4 is positive. 2 negatives make a positive, and so this overall value would be positive. It is not a solution. I'm going to test the number 4. 4 minus 1 is positive. 4 minus 6 is negative, and 4 plus 4 is positive. A positive times a negative divided by a positive is negative. Negatives are less than 0. This is a solution. And my last test point is the number 10. 10 minus 1 is positive. 10 minus 6 is positive. And 10 plus 4 is positive. And if you multiply 2 positives and divide by a positive, you get a positive, not a solution. So let's look at how we're going to write our answer. We're going to write it in interval form. I want all of the numbers that are between negative infinity and negative 4. Negative 4, if you look at the original function, is going to make the denominator 0. Therefore, I have to exclude it. So one interval is negative infinity to negative 4. I'm going to skip the interval between negative 4 and 1 because that makes the rational function positive, which is not less than 0. The other interval I'm going to choose is between 1 and 6. If you put 1 in, you get 0. 0 is not less than 0. And if you put 6 in, you get 0. 6 is not less than 0. So in this interval, I'm going to use parentheses again to exclude the endpoints or the boundary points. And then from 6 to infinity does not work because it makes it positive. So the solution to this problem, as long as you pick numbers inside these intervals, you have a solution. So that was number 1. Pretty easy. They gave it to us in factored form. Now, problem number 2 is a little more challenging because we have to combine these factors together. X's on each side are changing, so I need to always compare my inequality to 0 because I know all numbers that are either less than 0 or greater than 0 behave the same way. They're either positive or negative. So your first step in this problem would be to make it less than 0 by adding the 3 over x plus 5. Now I'm going to combine these together. My common denominator is x plus 6 times x plus 5. We've done this in an earlier unit. In the numerator, I'm going to have to multiply the first fractions top and bottom by x plus 5. So that's negative 2x minus 10. In the second fraction, I'm going to multiply the top and bottom by x plus 6. That's a 3x plus 18, less than 0. Well, let's simplify the top. Negative 2x and 3x make x. Negative 10 and 18 make a positive 8. Divided by x plus 6 times x plus 5, less than 0. Now this is just like the previous problem, but we'll quickly go through it. My intervals are, or my critical numbers are negative 8, negative 6, negative 5. I'm just going to space them out to give myself some room. And then I'm going to pick my test points. So I'm going to test negative 10, negative 7. Ooh, I'm going to have to do a decimal here. Negative 5.5 and 0. I'm ready to start plugging those into my rational function. Negative 10 plus 8 is negative. Negative 10 plus 6 is negative. And negative 10 plus 5 is negative. That's negative. It's going to work because negatives are less than 0. Negative 7 plus 8 is positive. Negative 7 plus 6 is negative. And negative 7 plus 5 is negative. That's positive. Not going to work. Negative 5.5 plus 8 is positive. Negative 5.5 plus 6 is positive. And negative 5.5 plus 5 is negative. This one's negative. It's going to work. 0 plus 8 is positive. 0 plus 6 is positive. And 0 plus 5 is positive. This gives me a net value that's positive. Not going to work. So the solution is the interval from negative infinity to negative 8, negative 6 to negative 5. This last example I want to look at because we are going to have to factor. So the numerator is x squared minus 7x plus 12. So two numbers that multiply to give me positive 12 and add to give me negative 7 are x minus 3 and x minus 4. And in the bottom, I have the difference in two squares, x plus 6 times x minus 6. So a few things that are different here. One is that I have 4 factors now, which means I have 4 critical numbers, and I'm going to have 5 intervals on my number line. So I'm going to tie this, hopefully, to graphing as well. So on my number line, I've got the number -6 is the smallest, followed by 3, and then 4, and then 6. And now let's look at our test points. I'm going to test -10, 0, 3.5, 5, and 10. So this time I've got 4 numbers. So on the interval where I put in -10, -10 minus 3 is negative, -10 minus 4 is negative, -10 plus 6 is negative, and -10 minus 6 is negative, and 4 negatives make a positive. If I put in 0, 0 minus 3 is negative, 0 minus 4 is negative, 0 plus 6 is positive, and 0 minus 6 is negative. 3 negatives stay negative, and this one was less than 0, so I'm going to use it. If it were greater than 0, then I would be picking the intervals where it was positive. 3.5 minus 3 is negative. 3.5, nope, it's not, it's positive, sorry about that. 3.5 minus 4 is negative, but 3.5 plus 6 is positive, and 3.5 minus 6 is negative. And so this gives me an overall value that's positive. Not going to work for this problem. 5 minus 3 is positive, 5 minus 4 is positive, 5 plus 6 is positive, but 5 minus 6 is negative. We get a negative. Use it. 10 minus 3 is positive, 10 minus 4 is positive, 10 plus 6 is positive, and 10 minus 6 is positive. That gives us a positive interval. Don't use it. Now this one was a little bit different because it was also equal to, and you have to be careful. You want to include the boundary as long as it doesn't make the function undefined. So 6 and -6 have to be excluded no matter what because they're in the denominator, but the 3 and the 4 you want to include because they will make it equal to 0, and 0 will be less than or equal to 0. So when I look at my intervals that work between -6 and 3 work, I can't use -6, but I must include 3. And my next interval is between 4 and 6. 4 makes the top 0, so I include it because 0 is less than or equal to 0. But 6 makes the bottom 0. I can't divide by 0, so I exclude it. So these are your 2 intervals. Now, I want to tie this to graphing a rational function. If I wanted to graph x minus 3 times x minus 4 over x plus 6 times x minus 6, I would have vertical asymptotes at 6 and -6. Let's say something like this. I would have x-intercepts at 3 and 4. I have a horizontal asymptote at 1 because of the ratio of the leading coefficients.
Taylor to the front office, please. Haley Taylor to the front office.
I have a y-intercept at 12 over -36, which is -1/3. And here's my graph. If I use my sign chart, it will help me. On the interval from -infinity to -6, my graph is positive. That's a branch up here. Between -6 and 3, my graph is negative. So from -6 to the number 3, my graph is negative. Between 3 and 4, my graph is positive. Between 4 and 6, my graph is negative. And between 6 and infinity, my graph is positive. That's a branch up here. So you can use sign charts to help you define where your branches go. Kind of ties those two things together. So in class, you will get a worksheet, and you will practice doing some of these test point inequalities. Good luck.